Welcome to the Regents Physics Kinematics problem set, the solution for number 14. 14 says, refer to the velocity time graph, pictured here as well, and find the acceleration of the moving object at each of the following time intervals, and they give us 4 various time intervals in A through D. Well, on a velocity time graph, how do we find acceleration? The acceleration, we'll start with A here for doing an example. The acceleration is the slope of the graph on a velocity time graph. So just like velocity was the slope on a distance time graph, the acceleration is the slope on a velocity time graph. So change in y over change in x. And choice A, or for problem A here, they want during the first 5 seconds of travel. So our change in y looks to be 30 meters per second. Our change in x looks to be 5 seconds. And so we get a slope, 30 divided by 5 is 6. 6.0 for 2 digits, and that would be meters per second per second. I'm going to show you a quick little lesson here on the units of acceleration. Meter per second, that's a double fraction. In order to simplify a double fraction, what we have to do is multiply both the numerator and the denominator by the reciprocal of the denominator. The denominator here is s. So the reciprocal is 1 over s, and we do that to both the numerator and the denominator. That cancels the s in the denominator, and we get 6.0 meters per s times s is meters per second squared. So our first interval here, the acceleration is 6 meters per second squared. You would do the same thing for the other intervals asked here. Let's take a look at B. They want from 5 to 10 seconds. Well, from 5 to 10 seconds, it's a horizontal line. So that means that the acceleration, of course, would be 0 meters per second squared during that interval. In C, they want between 10 and 15 seconds. That's this line right here. And so we have to find the slope of that line. Go ahead and pause if you've not done so already. Do your change in y over change in x. And you should get a value that's -2 meters per second squared. Notice the negative sign here indicated by the negative slope. And if you do your change in y or change in x appropriately, your change in y ends up being a negative value. For D, they want between 20 and 25 seconds. And that would be this interval right here. Go ahead and pause the video if you need time. Do your change in y over change in x. And you should get, when you're done, -4 meters per second squared. Again, I'll ask to see your work for those intervals, especially for C and D, showing your slope calculation. All right, more work with velocity time graphs tomorrow in class, when together we'll be doing number 15.